Chapter 1.2 Quick Review Exercises 1 through 10. Section 1.2 in our book has to do with finding domain and range of functions and also other attributes of functions. So this exercise set is a preliminary set to that. And we're going to go over in this video the odd number problems 1, 3, 5, 7, 9. And exercises 1 through 4 solve the equation or inequality. So we have this equation, which is x squared minus 16 is equal to 0. To solve this equation, we're going to isolate the x. To do that, we're going to first add 16 to both sides of this equation. And negative 16 plus 16 cancel. And we have left x squared is equal to 16. So rewriting x squared equals 16, how do we isolate this x? Well, we're going to take the square root of both sides of this equation. And we take the square root of x squared, we get x, and the square root of 16 is 4. Now, is this a correct answer? Well, I hope some of you said no. Because we solve an equation using the square root method, we have a plus or minus solution. And logically, if we look back at our original equation, x squared minus 16 equals 0, if we have x equal to negative 4, well, negative 4 squared is 16, and 16 minus 16 is 0, or positive 4 squared is 16, 16 minus 16 equals 0. So either one of these will work. I want to alternatively show you another way of solving this equation, which is by factoring, and that might help some of you down the road. Now, we can rewrite this quadratic binomial x squared minus 16 as a product of two linear binomial factors. This is called using a difference of squares method. Difference of squares. I hope you remember that from Algebra 2 or somewhere. So we take the square root of x squared, and that's going to be x and x, and we have plus minus. And then we take the square root of 16, well, the square root of 16 is 4, and we write 4 both places. Now we have the product of two linear binomials. And so using the zero factor property of algebra, we can take each of these factors and set each of these factors equal to 0. So we have x plus 4 is equal to 0, and on the right set x minus 4 is equal to 0. And then if we solve the left equation, plus 4 minus 4, so we have x is equal to negative 4. And on the right equation, if we add 4 to both sides of this equation, we have x is equal to 4. So we get the same result, an alternative way of looking at things. Let's go to our next odd number problem, which is 3. This time we have an inequality, and that is that x minus 10 is less than 0. So we solve an inequality for the most part just like an equation. There will be exceptions, but if we add 10 to both sides of this inequality, we have negative 10 plus 10 cancel, which equals 0. We have x is less than 10. And really, that's all there is to it. We have solved the inequality at this point. Now, for x is less than 10, if we write this in interval notation, our domain is going to be, and we haven't got an interval notation much, but will shortly, greater than negative infinity all the way up to 10. But is 10 included as part of the domain of the solution? No, it's not, because we have less than 10. Less than or equal to 10 would be a bracket. So it's just an alternative way of explaining x is less than 10. Inequality notation on the left, interval notation on the right. Next set, exercise 5 through 10, find all values of x algebraically for which the algebraic expression is not defined. Support your answer graphically. So we're looking at algebraic expressions, not a function, not an equation, but just expression. So what we look for in this, we look for exclusions. Exclusions would be where expression, or it could be a function, not defined. So we really have a quotient of two expressions. We have x in the numerator, x minus 16 in the denominator. Well, for x, if we had the equation y equals x, there would be no exclusions to the domain. So based on the numerator, no exclusions. So there's not a real number that x cannot be. Now in the denominator, that's a different story. We know, what do we know about math and an algebra? Can we divide by 0? No. So we know that x minus 16, this denominator, cannot be equal to 0. And to solve this inequality, we add 16 to both sides. And adding 16 to both sides of this inequality, x cannot equal 16. But we are being asked where the expression is not defined. So our answer is going to end up being x equals 16, because that's where this function is not defined. And for the last part, we're to support our answer graphically. We're just going to look at calculator and put in this function here, x over x minus 16. And what I'm going to do is just press enter, and we don't see a whole lot. I'm going to adjust the window, and I go to menu, window, and window settings. I'm going to go from x equals 0 as a minimum value of x, all the way up to 30 as a maximum value. And just to kind of see things better, I'm going to change the y minimum to negative 30 and the y maximum to positive 30. And we'll just see what this looks like. Okay, we have a vertical asymptote, or infinite discontinuity, at x equals 16. And also call that a non-removable discontinuity. So that's just graphical support. Next, under problem 7, we have square root of quantity x minus 16. So what we should know is what can we not do? We cannot take the square root of a negative number. So we know that what's inside this radical, x minus 16, has to be greater than or equal to 0. So we solve this inequality just like we would an equation. We add 16 to both sides. And we have x is greater than or equal to 16. Now this is for where the domain is. So our answer to where the function is not defined, x has to be less than 16. And graphically we can examine this. We go back, and I'm going to get a new page. Okay, we have add graph. We have the square root of x minus 16. Press enter. I don't see anything. We're going to have to change the viewing window. And we're going to go to Window Settings. There we go. And I'm going to go from 0 to 30, kind of similar to what we did in our last problem. And this is what we see. We see the function being defined at 16 and to the right. So what is not defined is x is less than 16. So that confirms our correct answer here. Last on the problem we look at is number 9. We have the square root of quantity x plus 2 over the square root of quantity 3 minus x. And so again, in the numerator, both the numerator and denominator, what are we looking for? We're looking for exclusions to the expression, or to the domain, if you want to call it. This is a function that would have a domain. And so, just looking at this, we know that we cannot take the square root of a negative number. So x plus 2 has to be greater than or equal to 0. In solving this inequality, we have x is greater than or equal to negative 2. And then for this 3 minus x, well, I'm tempted to write 3 minus x is greater than or equal to 0, but can we do that? No, we cannot. And here is why not. Not only can we not have this inside the square root bracket be negative, we cannot even have it be 0, because what? We cannot divide by 0. So what I'm going to do is take this little inequality that was greater than or equal to and just change it back to greater than. And so now, solving, if we subtract 3 from both sides of the inequality, we have negative x is greater than negative 3. And solving for x, we can divide or multiply by negative 1. I'm going to divide both sides of this inequality by negative 1. So negative x divided by negative 1 is x. And negative 3 divided by negative 1 is 3. But we divide by a negative number, so we have to change the direction of our inequality. So we have two conditions. X is greater than or equal to negative 2, and also x is less than 3. To examine what this looks like, if we just take a number line, it can be very helpful to us, and just mark our critical numbers. Our critical numbers are going to be negative 2 and also 3. And what happens at negative 2? Well, at negative 2, we have negative 2 is defined, so we draw an open point. And at 3, we have less than, so I'm going to draw kind of an open point. So I have a closed point at negative 2, open point at positive 3, and so we just fill in between the negative 2 and the 3. So that's what that looks like. And graphically, we've found out what x is going to be, but we have to take the opposite here. So x can be greater than or equal to 3. We can see this, right? I mean, that's for what x cannot be. And also x has to be less than 2 or negative 2. So that's what, and we've kind of supported graphically just using a number line graph. Let's support graphically with a two-dimensional graph. And if we go up here to two-dimensional graph, put square root of x plus 2 divided by square root of 3 minus x And if we graph this, this is what we get. Can't see hardly anything of it, so I'm going to go ahead and adjust the window back again. 4. I'm going to go to 5, zoom standard, and this is what we look like. So we can see that the function is defined from, looks like, -2 all the way up, but not including +3. And so the function is not defined at less than -2 or at greater than equal to 3. So that confirms our answer here. So those are all the odd number problems being worked out. The even number problems are okay. Watch for dividing an inequality, dividing by a negative number to solve. That's where you'll need to switch the direction of the inequality symbol. Again, I hope this has been helpful for you. Good luck, and thanks for viewing.